Welcome back to Knowledge Academy's YouTube channel. Now that we've covered the basics of the k-nearest neighbors algorithm, it's time to put theory into practice. In this hands-on example, we'll build a real-world KNN classification model to predict whether a customer will make a purchase based on their online behavior. By the end of this session, you'll understand how to pre-process data, train a KNN model, and evaluate its performance using Python. To demonstrate the KNN algorithm, we'll use a dataset containing features like time spent, pages visited, and clicks. The target variable, which is purchased, indicates whether the customer completed a purchase that is 1 or not, which is 0. First, let's load and examine the dataset. Start by importing the necessary libraries and loading the data. Link to the dataset is given in description below. First, we will import pandas and numpy, and then we'll use the scikit-learn library and a customer behavior dataset to predict whether a customer will make a purchase. Let's start by importing the necessary libraries and understanding their roles. First, train test split. It splits the dataset into training and testing sets. Next is standard scaler. It standardizes features by scaling them to a mean of 0 and a standard deviation of 1. Next is k-neighbors classifier. For the KNN, model from scikit-learn used for building and training the KNN classification algorithm. Next, confusion matrix. It evaluates the model by showing the counts of true positives, true negatives, false positives, and false negatives. Last is accuracy and fun score. This measures the overall performance of the model, with accuracy and the F1 score. With these tools ready, let's dive into loading and pre-processing our dataset. Now, let's load the dataset to start working with it. We'll use the pandas library to read in the data. We load the customer behavior data from a CSV file using the pd.readcsv. After loading the dataset, we can inspect the first few rows using printdata.head. This step gives us a snapshot of the dataset to understand its structure and identify any missing or unrealistic values. Next, we'll clean the data to ensure our model's accuracy. Real-world datasets often contain missing or incorrect values that can affect the results. We'll replace any 0 values with NaN using replace function. Then we'll use fillNA to replace these missing values with the mean of their respective columns. This ensures that the dataset is consistent and ready for analysis. This step prepares the dataset by handling any anomalies that might skew the model's predictions. Now, once the dataset is clean, we'll split it into training and testing sets. This is essential to evaluate the model's performance on unseen data. Using scikit-learn's train test split function, we divide the data into features X and target Y variables. After this, ensure the target column is numerical by using as typeint on target. Then we split these into training, that is 80%, and testing, which is 20% datasets. This step ensures that the model is trained on one portion of the data while being tested on unseen data, providing an unbiased evaluation. After this, we go on to check the shapes of the splits. So for this, we will use .shape in both feature and target variable. xtrain.shape and ytrain.shape shows the number of rows and columns in the training data, whereas the same with test show the number of rows and columns in the testing data. This returns the dimensions of the arrays, helping you ensure that the data has been split correctly. Now we will convert target variables to 1D array. This is done to ensure that the target variables ytrain and ytest are in the correct format for machine learning models. So for this, we will write as etrain equal to ytrain.valued, and then same for utest as well. By default, train test split may return itrain and utest as pandas series or data frames. Some machine learning algorithms require the target variable to be a 1D array. The dot values convert the pandas series into a 1D numpy array, which is the format expected by most scikit-learn algorithms. This has many models, including KNN, expected target arrays to be in one format for training and prediction, and this step ensures compatibility. Because KNN is a distance-based algorithm, it's essential to ensure that all features contribute equally to the distance calculations. Features with larger numerical ranges can dominate smaller ones, so we standardize the data. We use scikit-learn standard scaler to transform all features to have a mean of 0 and a standard deviation of 1. This step ensures that each feature has an equal impact on the model. Standardizing the data ensures that no single feature disproportionately influences the classification result. Now, we'll build the KNN classifier and train it using the prepared data. Using scikit-learn's k-neighbors classifier, we set the number of neighbors k to 5 and fit the model to the training data. The model learns by storing the training dataset and using it to classify new data points. This step creates a model capable of predicting whether a customer will make a purchase based on their online behavior. With the model trained, we can now use it to make predictions on the testing dataset. The predict method generates predictions for the testing data based on the learned patterns from the training set. The output is a set of predictions, 1 for purchase and 0 for no purchase, corresponding to each data point in the test set. Then finally, we'll evaluate the performance of our KNN classifier using confusion matrix, accuracy and the F1 score, and then print it one by one. We will use the confusion matrix. This provides insight into the number of correct and incorrect predictions for each class or no purchase. These metrics quantify the overall effectiveness of the model. Accuracy measures the percentage of correct predictions, while the F1 score balances precision and recall, offering a more comprehensive evaluation. This step allows us to assess how well the model performs and identify areas for improvement. In this hands-on tutorial, we walk through the process of implementing KNN classification model step by step. From data cleaning and pre-processing to training the model and evaluating its performance, you now have the tools to use KNN in your own projects. If you found this tutorial helpful, don't forget to like the video, subscribe to our channel, and explore our other tutorials for more hands-on machine learning examples. Until next time, happy coding!